Welcome to the Unit 3, Section 2 video on domain and range. Recall that a discrete function consists of a graph whose points are not connected. Discrete functions consist of a set of ordered pairs. The domain of a discrete function is the set of first coordinates, or x values, of the ordered pairs. The range of a discrete function is the set of second coordinates, or y values. So your domain is your x values, your range is your y values. When listing the domain and range, each value only needs to be listed once. So very similar to how you looked at a mapping diagram. You only have to list the values one time. It is good practice to list the domain and range values from most negative to most positive. So, in other words, in numerical order. So let's identify the domain and range for each of these discrete functions. In A, we have a set of ordered pairs. So all you have to do for the domain is write down all of your x values in a set of curly braces. For your range, you just have to write down all of your y values in curly braces. And you'll notice that two of the coordinates have a y value of 5. So that 5 only needs to be written once. You do not have to write your range values in the same order as your domain values in the order that the ordered pairs are in. All you have to do is list the values. And again, it is good practice to go from most negative to most positive. Write them in numerical order. For B, we have a table. Very similar to how we did the ordered pairs. You're going to take all your x values and you're going to write them down in a set of curly braces for your domain. For your range, you're going to take your y values and you're going to write them in curly braces as well. But you'll notice 4 occurs twice and 5 occurs twice, so you only have to write down each of those numbers once when you're writing down your range. For C, we have a graph. So here, I would follow the x-axis from left to right and write down all of the x values in which there is a point either below or above it. So we've got -3, -1, 0, 2, 3, and 4. Then start at the bottom of your graph and write your range values. So look along your y-axis and write down all the points that are either to the left or to the right of that y value. So we have -3, 0, 1, 2, and 4. And then finally, for a mapping diagram, this is the easiest of all. All you have to do for your domain is write all the values that are listed in the x, and for the range, write down all the values that are listed in the y. Because a mapping diagram also does not repeat values, you don't have to worry about finding values that repeat and writing them only once. Now let's talk about continuous functions. Recall, a continuous function is one that can include fractions or decimals. Graphically, it is represented by a continuous line. Because a continuous line represents an infinite number of solutions between the two ends of the line, we are going to use interval notation or set notation. So let's talk about the two types of notation for continuous functions in writing our domain and range. In interval notation, it is a way of expressing a set of real numbers by using the numbers that bound them. So for example, if we have a continuous line and we have an open dot or a closed dot or an arrow, these are the symbols that you will use. For an open dot or an arrow, you're going to use a parentheses because that indicates that the end is not included. And we do not include infinity, which is what is indicated by an arrow. A closed dot means that we are including the value, so we use a bracket to indicate that it is closed on that end and that the value is included. Interval notation is what you're going to be using more of when you're writing domain and range and other types of things that we're going to be looking at on graphs in terms of key features. But you also have the ability to use set notation, where we use greater than, less than, greater than or equal to, and less than or equal to. So let's go over this as well. Set notation is a way of expressing a set of real numbers by using inequalities. So again, for using an open dot or an arrow, you're going to use a less than or greater than, which means that it's open and not included. So there's no equals to, meaning it's not included. For a closed dot, you will use the equals to, indicating that it is closed or included. Now, I did say greater than or less than, greater than or equal to, or less than or equal to. When you use set notation, you're going to be going from most negative to most positive. So the less than and less than or equal to signs are the ones that are really going to get used when you write set notation. And we'll go over some examples of this. So let's talk about the different situations that you will have when looking at a continuous function. So the first one is two endpoints. First, you're going to find the location of the two endpoints. You're going to use parentheses if the point is not included, indicating by an open circle. You're going to use brackets if the point is included, which is indicated by a closed circle or a solid line. Always look for the points furthest left and right for the domain. Always look for the lowest and highest points for the range. So let's do an example of this. We are going to determine the domain and range for each continuous function, and we're going to use both interval and set notation. So in A, we have a closed dot on both ends. For the domain, we're going to look most left. So our most left-hand value on the x-axis is -4. Our most right-hand value on the x-axis is 2. So we're going from -4 to 2, and we use a bracket on both ends, indicating that both the -4 and the 2 are included. For set notation, we are going to use -4 is less than or equal to x, which is less than or equal to 2. Here you can kind of see in set notation that x sits between -4 and 2, and because we have the equals to, both -4 and 2 are included. Now, we used x values for the domain. Now we're going to go to our y values for the range. So we look at our lowest y value, the one that is furthest down. So if we look down the y-axis, the lowest y value that we have is -3. Then we follow the graph up, and the highest it goes is 6. And because we have the closed dots on both ends, it's -3 to 6. In set notation, we are going to have a similar thing. -3 is less than or equal to y, which is less than or equal to 6. So in the domain, you use x in set notation. For the range, you use y, because those are the values we are looking at. For B, we have, again, a continuous function. This time for the domain, we have on the left-hand side an open dot at -7, and on the right-hand side a closed dot, meaning we are including the 6, and we're going to use a bracket in interval notation. So parentheses, -7 to 6, closed bracket. Okay. For set notation, we're going to use our inequalities, but there will be no equals to on the -7 because -7 is not included. For the range, we're going to look at our y values. Now be careful. That doesn't necessarily mean we're looking at the ends of the graph like we did for the domain. Because if we start at -5, you see the graph is decreasing all the way down to y equals -9. -9 is the lowest place where this graph exists. The highest place that it exists is at y equals 0, which is along the x-axis. So we go from -9 to 0, and because we're touching at both the bottom and the top, those values we're going to include both in interval notation and in set notation. Now let's talk about a situation where we have one endpoint and then we go infinite one direction. The steps are going to be very similar. Find the location of the endpoint using the x-axis for domain and y-axis for range. Use the infinity symbol to represent the infinite direction. Use positive infinity for arrows pointing right in the domain and up in the range. Use negative infinity for arrows pointing left in the domain and down in the range. So let's do an example. For A, we are not including -4 on the left-hand side, but then we have an arrow on the right-hand side indicating that we're going infinitely in the positive x direction. And again, when we have infinity or an arrow, we're not including it. So in interval notation, we're going to have a parentheses on both sides because we're not including -4 and we never include our infinity. In set notation, it's just all values that are greater than -4. So you will just say x is greater than -4 because we go infinitely into the infinite direction in the positive x direction. For the range, our lowest y value is at -4, but we don't include it, so there will be a parenthesis there. And then we go to infinity because the arrow goes up infinitely, so y is greater than -4 in set notation. For B, we have an arrow on the left indicating in the domain along the x-axis, we are going in the negative infinity direction. Then we go all the way up to 6 and we include the 6. In set notation, it's all values that are less than or equal to 6. In the range, our highest value is y equals 4, and it touches, so we will include that 4. The arrow points downward, so we are going infinitely in the negative y direction, so we've got negative infinity to 4 at the top. So y is less than or equal to 4 in set notation. Finally, when we talk about a graph that goes infinitely in both directions, the domain, you're going to focus on the left and right ends of the graph. If one arrow is on the left and the arrow on the other side on the right, then the domain is always going to be negative infinity to positive infinity. For the range, focus on the top and the bottom ends of the graph. If one arrow points up and the other points down, then the range is going to be negative infinity to positive infinity. So in this first example, our domain, we look at the left-hand side, there's an arrow. On the right-hand side, there's an arrow. So we're going infinitely to the left and infinitely to the right. So our interval is negative infinity to positive infinity. And in set notation, we're going to use an R that's double striped to indicate all real numbers. For the range, we have an arrow pointing down and an arrow pointing up. So along the y-axis, we're going infinite in both directions. So we go in negative infinity to positive infinity, and we use all real numbers for set notation here as well. For B, we have, again, an arrow on the left and an arrow on the right. So our domain is negative infinity to positive infinity, or all real numbers. For the range, both arrows are pointing up. So we're going infinitely in the up direction, or the positive infinity direction. But we do have a bottom bound, and that is at y equals -6. And we do touch -6, so we're going to include it. So we use a bracket on that end. For set notation, it's all values that are greater than or equal to -6. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.